In this demonstration, you'll learn how to set up a structural analysis involving nonlinear contacts and display the contours for some contact results. To start, I'll select the structural template from the study panel, and then select a static analysis. On the options list, I can specify if I want to have the contacts between the adjacent faces of the bodies detected automatically and then generated using default settings. I'll select this option so that contacts are generated as part of the template process. AIM now prompts me for my model. I'll select the file for this brake disc. AIM loads the geometry and sets up a simulation process with default settings for geometry, mesh, physics, and results. This model consists of a brake disc and 2 brake pads with a 0.1 mm gap between the disc and each pad. 2 contacts between the disc and the 2 pads were automatically generated, along with a set of behavioral properties that applies to both. You can see these contacts here. At the bottom, you can see the behavioral properties for this generated contact. I want to change this contact type to frictional and then set the frictional coefficient. I need to apply a support to the interface of the disc to prevent it from experiencing a rigid body motion. A hinge joint is appropriate for this purpose since it allows the disc to rotate. I'll select the face and create a new joint. Because I selected only one face, this joint is created as body to ground. Then I create a new joint behavior, which defines the properties for the joint. Here I set the type to hinge. My joint definition is now complete. Now I need to define some boundary conditions. I'm going to skip ahead. I've defined 4 boundary conditions. Here, I've set an inertia load on the disc body, with the inertia source specified as angular velocity and the reference frame set to the joint. The magnitude is defined about the z-axis. I've also set 2 displacement conditions. The first is set on the faces of the first pad body. The second is set on the faces of the second pad body, with a negative value so that the direction of the displacement is toward the disc body. Finally, I've set a pressure on the outer top face of the 2 pad bodies. Now I'll solve the physics. While it is solving, I can see the output from the solver here. Now that my analysis is solved, I'm going to add contour results for the contacts here in the Results task. I want to be able to see the contact status, contact frictional stress, and contact gap, not only at the final result set, but also at the intermediate result sets. Now I'll update so I can view these contour results. You can see the final contour of the contact status, contact frictional stress, and contact gap. By moving the slider and re-evaluating, you can see the contours at the various intermediate result sets. This concludes this demonstration of nonlinear contacts.